Smart contract. A smart contract is a computer program or a transaction protocol which is intended to automatically execute, control or document legally relevant events and actions according to the terms of a contract or an agreement. The objectives of smart contracts are the reduction of need in trusted intermediators, arbitrations and enforcement costs, fraud losses, as well as the reduction of malicious and accidental exceptions. Vending machines are mentioned as the oldest piece of technology equivalent to smart contract implementation. 2014's white paper about the cryptocurrency Ethereum describes the Bitcoin protocol as a weak version of the smart contract concept as defined by computer scientist, lawyer and cryptographer Nick Szabo. Since Ethereum, various cryptocurrencies support scripting languages which allow for more advanced smart contracts between untrusted parties. Smart contracts should be distinguished from smart legal contracts. The latter refers to a traditional natural language legally binding agreement which has certain terms expressed and implemented in machine-readable code. History. Smart contracts were first proposed in the early 1990s by Nick Szabo, who coined the term, using it to refer to a set of promises, specified in digital form, including protocols within which the parties perform on these promises. In 1998, the term was used to describe objects in rights management service layer of the system, the Stanford Infobus, which was a part of Stanford Digital Library Project. Legal status of smart contracts. A smart contract does not necessarily constitute a valid binding agreement at law. Some legal academics claim that smart contracts are not legal agreements, but rather means of performing obligations deriving from other agreements such as technological means for the automation of payment obligations or obligations consisting in the transfer of tokens or cryptocurrencies. With the 2015's implementation of Ethereum, based on blockchains, smart contract is mostly used more specifically in the sense of general-purpose computation that takes place on a blockchain or distributed ledger. The U.S. National Institute of Standards and Technology describes a smart contract as a collection of code and data, sometimes referred to as functions and state, that is deployed using cryptographically signed transactions on the blockchain network. In this interpretation, used for example by the Ethereum Foundation or IBM, a smart contract is not necessarily related to the classical concept of a contract, but can be any kind of computer program. A smart contract also can be regarded as a secured stored procedure, as its execution and codified effects like the transfer of some value between parties are strictly enforced and cannot be manipulated, after a transaction with specific contract details is stored into a blockchain or distributed ledger. That's because the actual execution of contracts is controlled and audited by the platform, not by any arbitrary server-side programs connecting to the platform. In 2017, by implementing the Decree on Development of Digital Economy, Belarus has become the first ever country to legalize smart contracts. Belarusian lawyer Denis Oleinikov is considered to be the author of a smart contract legal concept introduced by the decree. In 2018, a U.S. Senate report said, while smart contracts might sound new, the concept is rooted in basic contract law. Usually, the judicial system adjudicates contractual disputes and enforces terms, but it is also common to have another arbitration method, especially for international transactions. With smart contracts, a program enforces the contract built into the code. A number of states in the US have passed legislation on the use of smart contracts, such as Arizona, Nevada, Tennessee, and Wyoming. Implementations. Similar to a transfer of value on a blockchain, deployment of a smart contract on a blockchain occurs by sending a transaction from a wallet for the blockchain. The transaction includes the compiled code for the smart contract as well as a special receiver address. That transaction must then be included in a block that is added to the blockchain, at which point the smart contract's code will execute to establish the initial state of the smart contract. Byzantine fault-tolerant algorithms secure a smart contract in a decentralized way from attempts to tamper with it. Once a smart contract is deployed, it cannot be updated. Smart contracts on a blockchain can store arbitrary state and execute arbitrary computations. End clients interact with a smart contract through transactions. Such transactions with a smart contract can invoke other smart contracts. These transactions might result in changing the state and sending coins from one smart contract to another or from one account to another. Additionally, the programming languages with various degrees of Turing completeness as a built-in feature of some blockchains make the creation of custom sophisticated logic possible. Measurement using regular expressions showed that only 35.3 of 53,757 smart contracts from Ethereum included recursions and loops. Those are connected to halting problem. Due to halting and other security problems, Turing completeness is considered to be a risk and is deliberately avoided by languages like Viper. Some of the other smart contract programming languages missing Turing completeness are Simplicity, Scilla, Ivy, and Bitcoin script. An example for Turing complete languages is the object-oriented smart contract language Solidity. Processes on a blockchain are generally deterministic in order to ensure Byzantine fault tolerance. Nevertheless, real-world application of smart contracts, such as lotteries and casinos, require secure randomness. In fact, blockchain technology reduces the costs for conducting of a lottery and is therefore beneficial for the participants. Randomness on blockchain can be implemented by using block hashes or timestamps, oracles, commitment schemes, special smart contracts like Ranow and Quantu, as well as sequences from mixed strategy Nash equilibria. Replicated titles and contract execution. In 1998, Sobor proposed that smart contract infrastructure can be implemented by replicated asset registries and contract execution using cryptographic hash chains and Byzantine fault-tolerant replication. AskMoss implemented this approach in 2002 using Scheme, later adding SQLite as contract script language. One proposal for using Bitcoin for replicated asset registration and contract execution is called colored coins. Replicated titles for potentially arbitrary forms of property, along with replicated contract execution, are implemented in different projects. As of 2015, UBS was experimenting with smart bonds that use the Bitcoin blockchain, in which payment streams could hypothetically be fully automated, creating a self-paying instrument. Security issues. A blockchain-based smart contract is visible to all users of said blockchain. However, this leads to a situation where bugs, including security holes, are visible to all yet may not be quickly fixed. Such an attack, difficult to fix quickly, was successfully executed on the DAO in June 2016, draining $50 million in Ether while developers attempted to come to a solution that would gain consensus. The DAO program had a time delay in place before the hacker could remove the funds. A hard fork of the Ethereum software was done to claw back the funds from the attacker before the time limit expired. Issues in Ethereum smart contracts, in particular, include ambiguities and easy but insecure constructs in its contract language Solidity, compiler bugs, Ethereum virtual machine bugs, attacks on the blockchain network, the immutability of bugs and that there is no central source documenting known vulnerabilities, attacks and problematic constructs. Difference from smart legal contracts. Smart legal contracts are distinct from smart contracts. As mentioned above, a smart contract is not necessarily legally enforceable as a contract. On the other hand, a smart legal contract has all the elements of a legally enforceable contract in the jurisdiction in which it can be enforced, and it can be enforced by a court or tribunal. Therefore, while every smart legal contract will contain some elements of a smart contract, not every smart contract will be a smart legal contract. There is no formal definition of a smart legal contract in the legal industry. A Ricardian contract is a type of smart legal contract.